All right, this is section 4.5, day 2. We're going to take all the things we learned about in the previous lesson about the way trig functions look in terms of their equation, and then we are going to graph them today. So we're going to put all that into practice and create our own graphs. So the first one we're going to graph is kind of a simple one. We're just going to do y equals negative 2 sine x. So we know that this negative is going to flip the graph, and we know that this 2 is going to affect its amplitude. So how high or how low it goes, or how high those bumps are. This is the order that I always teach kids to graph them in. So first you want to determine your vertical shift, if you have any. We don't in this problem. So for us, it's going to be an NA. Amplitude is next, so that's your A, and that's what's found right in front of your trig function. So for us, that's a 2. So since I did not have a vertical shift at all, I'll just go up 2 and down 2 from the x-axis. So this is like the top, and this would be the bottom of my graph. It has to touch the dotted line, but it can't go beyond that. That's kind of like my high and low limits. Next up, we're going to determine the period. That is always what's in front of, what's in front of the x. And we have a 1 there, so we would go 2 pi over 1. So our period is 2 pi. I'll come out here to 2 pi, and I'm just going to kind of close off this little rectangle I'm making, this box. And I'm going to chop it up into 4s because that's what we have talked about in terms of our values like around the unit circle. We're always in those 4 quadrants. So we want to chop it up into 4s and makes our graphing kind of a little bit easier. So create box limits, that's what I did. That's my top, that's my end for my period, and then my bottom for the rest of my amplitude. So our job is to put the function in this entire box one time. It has to fill the whole space, so high and low, and from left to right. So it has to fill that whole rectangular dotted box. And this is a sine function, so I'm going to start in the middle. And a sine function normally would then go up, back to the middle, down low, and then back to the middle. So it would kind of have this shape to it. I'm making this really light because what we have to still adjust for is if there is a reflection. And we have one, so we are going to go ahead and move all of these dots. We're just going to flip them all. So instead of starting in the middle and going up, we're going to start in the middle and go down. So I'm going to hit that one, I'm going to go back to the middle, I'm going to hit high, and then back to the middle. All right. We like to graph 2 full periods, so I'm going to continue my graph out this way. So I'm going to go negative 2 pi out here. Negative pi, I'm just going to kind of continue my dotted lines so I know how high and how low I need to go so I don't mess that up. And then we're just going to continue the pattern. So if I went high, middle, low, middle, high, middle, low, back to middle. And now I've got 2 full periods of that graph. Couple more to go here, and then we're going to try writing equations. So this one first, again, I'm going to do it in DAB order. So D first, and I have a vertical shift at negative 2. So my graph is going to go down negative 2. This is going to be like the new middle of my graph. This is like the new x-axis for me. Next up is A. So do I have an amplitude? I do. It's only going to be a half. So from there, sorry, hold on. I didn't pay attention that my amplitude was a half. So I'm going to make these just a little bit bigger so I don't have to graph so tiny. So we're at negative 2. And then I'm only going to go a half up from there and a half down from there. So this is going to be your slinky is super shrunk compared to this one where we were kind of stretched up a bit. This one's going to be super tiny, squished down. B, I need my period. That's just a 1 right there, so 2 pi over 1 means my period's going to be 2 pi. So I'm just going to kind of close that rectangle, that box off, so I know exactly how much space I have to work in. Remember, this is the top of your graph, this is the bottom, and this is that middle, so those are those 4 key points we're going to hit. And I'm just going to give myself 4 little tick marks to kind of match up above so that I kind of know where my hitting places are so I don't miss those. So cosine function should start as high as it possibly can, so that's as high as it can be. It's going to hit the middle, come down, middle, and back up, so that it has that U shape we talked about when you are graphing it. And we do like 2 full periods, so I'm going to go ahead and graph over here, negative 2 pi, negative pi, just chopping it up into 4s. I'm going to keep those dotted lines going just so I have a good sense of what's my high and my low so I don't go outside of that space. And we were low, middle, high, so we would go middle, low, middle, high, just keeping the pattern going. One mistake students do make, and it wouldn't make sense on this one, but on this one, like when you graphed that first half, I should have talked about when we did this, it's not a mirror image, so I'll have students just start from here and go back down to like mirror this side. You want to keep your pattern going, so remember no sharp turns in your roller coaster. If this turned and went down right away, you'd have a pretty sharp curve right there. So if you're like middle, high, middle, low, middle, high, middle, low, like keep your pattern going even for this one. So we were high, middle, low, high, middle, low. So it's got to maintain that pattern. We got to have a nice wavy snake or a nice roller coaster ride. One more that we're going to graph, then we'll do some writing equations. So this one I'm going to start with D, and it looks like I'm up 1. So this is the new middle of my graph. Get that extended both directions. A is next. My amplitude is a 1. B, period. So my period is actually going to be related to this 1/2 sitting here. So it's not just a 2, but it's that fraction of a half. So we would have 2 pi over a half. We're going to fix that because we don't leave a stacked fraction. So this ends up being that my period is actually 4 pi. And this would be 2 pi. And, oh, so sorry, we didn't do amplitude. So from here I would go down 1, so the axis is one of my dotted lines, and then from here I would also go up 1. So here's my top. Sorry, I got so distracted I kept going. Keep those dotted lines going in both directions. This will be my negative 4 pi, negative 2 pi. All right, so now I can see the rectangle of space that I should have that I'm going to fill from top to bottom and left to right. I fill that whole space with one sine function in there. And it has a negative, so we also have a oops, my lights turned off. So we also have a reflection. So sine is supposed to start in the middle and go up, so we're going to start in the middle and go down right away. Back to middle, up, back to middle. I'm just going to keep that pattern going, so high, middle, high, middle, low, middle. And I just keep hitting on those like key 4 places that we chunked this up into. So that's how I'm deciding where to hit, is every those 4 chunks that we divvied up the x-axis into. And now I just got to connect them. And I've got my function. All right. Next up, we're going to write the equation for a couple of graphs. So kind of in reverse, if I gave you the graph, could you write me the equation? What's kind of tricky is you can write them all as either sine or cosine functions. And most of the time when you get a worksheet, I'm going to have you write it in both so you can practice. One will be easier than the other. Usually the graphs are set up to be either a sine or a cosine function more easily, but we'll definitely practice doing them both ways. So here are just some little tricks about how to find each of the parts. Amplitude can actually be found by taking your highest value and your lowest and dividing by 2. And remember, that's a y value. So your highs and lows are your y's. Your b can be found by doing 360 divided by period or 2 pi divided by period. Remember that that's equivalent, so you can use either one of those if you would like to write in radians or in degrees. Which trig function fits the best? That's where I was talking about some of them. Fit one trig function better than the other. And then our d shift, so that up or down, is found by doing high plus low divided by 2. So the same values, you're just going to add them instead. And then we always look for a reflection at the end, see if we got to flip it. So this first one, I'm going to do amplitude first. So amplitude is going to be my highest value, which is 1, 2, 3, 4, 5, 6. That's my highest. I'm going to subtract my lowest, which looks like it's at negative 2. I'm going to divide by 2, so I've got 8 over 2, which means my amplitude is 4. Next up is period. So my period, I'm looking for a high point to a high point, or maybe a low, oops, you can't see it, a low to a low. You can even do like a middle up to a middle up, but you have to be doing 2 of the same type of points. So bottom, bottom, top, top, middle up, You could do a middle down with a middle down, but you just have to match up two of the same type. So I'm going to just use high to high because that's kind of the easiest in this picture. And that space from there, which was at 0, all the way over to here, which is 360. So that means that my period is 360 degrees, or 2 pi. And so that means my b is going to be 360 divided by 360, or just a 1. So whichever trig function we choose, it'll just be a 1 before we write our theta. So now which trig function fits it best? For this one, since we have a high point on the y-axis, it's like starting high, that fits a cosine much better than a sine. So we'll do cosine for this one, and I'll show you also how to write it as a sine. Next up, we got to decide if there was a horizontal shift. So if you decided to go with cosine and it's doing what it should do, like this one is, because cosine is supposed to be a high point starting there. So that's great. We do not have a horizontal shift for that. When we go to do our sine, I'll show you what that'll look like. Then we've got d to figure out yet. So d is supposed to be high plus low, so same values, 6 and -2. And so I'd have 4 divided by 2, so it looks like my d, or my vertical shift, is at 2. And you could just quick sketch that and just go, do I think that that's the middle? Do I have the same amount above as I do below? And yep, I do. So that 2 is right in the middle. If we want to write this as a sine function, everything stays the same. The only thing that changes is you will have a shift. Since this is not behaving like a sine function right now, it looks like a cosine function. In order for us to do sine, we have to actually go and find a middle point, so either this one or this one. Sine is supposed to be a middle going up, so this is the easier one to pick. So I need to know how much over that is so I can compensate with my shift. So if that's 180 and that's 360, smack in the middle of them would be 270. So that's my shift. And I don't care if you write it as 270 or 3 pi over 2. It doesn't matter to me if you work in radians or degrees. I speak both languages. One more to go. We're going to do all the exact same steps, and we're going to write it both as a cosine and as a sine function. So first we're going to find, let's do it down here. First we're going to do A. So amplitude is highest value, which looks to be at 1. Minus lowest value, which looks to be at -3, divided by 2. So amplitude looks like it's 2. Let's figure out our period. So you could go from a middle down to another middle down. I'm going to do that. I like to use the ones that start on the y-axis because that signifies 0. So then all I have to do is figure out where I landed, instead of trying to go from here to here. So now I'm halfway in between these two, and I got to figure out how far it is to be halfway in between these two. So it's a little harder to do. If you can pick something on the y-axis, that's what I start with, because then you're starting at 0. So to go from this point to its match takes exactly pi to do that. So my period would be 2 pi over pi. And I'm using 2 pi because I'm in radians. You could also have done 360 over 180. You would just have to, mentally change that into 180. Cross off my pi's or reduce this, you end up with a 2. So in your formula, you have a 2 on your b, or sorry, for your b, so that is what goes on your theta. This function fits a sine better. On the y-axis, you are going through your halfway point, not a high or a low. So this fits sine better. And the last one we have to do is d. So our high was 1, our low is -3, which would be -2 over -2 for -1. So we have a downshift of -1. To write it as a cosine function, everything stays the same. The only thing that changes is you're going to have a shift in here with your theta. Cosine, oh my gosh, sorry. This is starting at a middle point going downward. We need to throw a negative on there because it's sine should be starting at the middle and going up, and we're going down, so we need a negative. So sorry, I missed that. This cosine function, everything's the same. Cosine is supposed to start at a high place, and it's not. It's starting in a middle place. So if we want this to be a cosine function, we need to go pick one of these high places, or you could pick a low place. You would just have to put a negative in front. I'm going to pick a high one, just to keep it simple. And this was pi, so half of pi would be pi over 2. And if you use your unit circle, you can figure out what's right in the middle between pi over 2 and pi. And it is 3 pi over 4, or 135 degrees. and we are shifting 3 pi over 4. So I'll throw that shift in there, and then that would create this graph as a cosine. So today is just putting together all the things you've learned about amplitude, period, vertical shift, horizontal shift, and starting to graph.